Hello everyone. Through this video, we are going to discuss a new concept, circular permutations. Till now, in my previous videos, we went on discussing about arrangement of things in a straight line. In other words, all these discussions were related to specifically linear permutations. Linear permutations. Through this video, we are going to discuss about circular permutations. In case of circular permutations, there is neither the beginning nor the end. So till now the discussions were made on linear permutations. From this video onwards, we shall be starting with a new concept, that is circular permutation. Circular permutation will always be, from the name itself it is very clear that it will be of course related to a circle. Suppose linear permutation is this kind of permutation where arrangements is done either row wise or column wise, not in a circular manner. So when the things are constructed row wise or column wise, in that case there is certain sequence of arrangement. But in case of circular arrangement, suppose 5 things are arranged in this circle. Now what is the starting point, what is the ending point, that is not clear. Things will be more clear if we consider an example here. Say for example, suppose I consider that 5 persons are to be arranged in such a way that they can sit in a row. They can sit in a row. Now in previous cases, in earlier videos already we had gone through in what way we could make the arrangement. Suppose 5 persons are there, so we have to construct 5 positions which will be arranged in a row. Say 5 divisions I made here: first seat, second seat, third, fourth, and this is a fifth seat. Say first seat, then second seat, then here this is third one, then after this is fourth one, then this is the fifth one. Now as there are 5 persons, how many possible ways to make the arrangement for the first place? We have 5 options in my hand. Suppose this can be done without repetition. We add one more thing, since this is permutation, we add one extra part here, an extension here, in which repetition is not allowed. Repetition is not allowed. So here in this case we are having 5 options in my hand to fill up the first place. Means as 5 persons are there, any one of them can sit in the first place. Since repetition is not allowed, here in this case repetition is not allowed, therefore how many options left in my hand to fill up the second place? Of course there are 4 persons left, any one of them can sit here. Similarly, for the third place, how many options are left? 3 persons were there, 3 persons were remaining, any one of them can sit here. Means there are 3 possible ways to fill up this third place. Similarly, for the fourth place, for filling up this position, there were 2 options left in my hand, and for the last place there is of course 1 option. So here in this case, the possible number of ways of making this arrangement will be equal to 5 into 4 into 3 into 2 into 1, that is equal to 5 factorial. Now, whatever we had discussed just now, these things are entirely related to linear permutation. Why did I call to be linear permutation? Because the persons were arranged in a row wise. So where there is a question of row or column, of course the term linear will come here. Row means they will sit in a straight line. There will be a specific sequence. So here in this case, this is all about linear permutation. The same question, if I consider here once again, and if I suppose consider 5 persons are to be arranged in such a way that they can sit in a circle and not in a row, in which repetition is not allowed. So in this case, what will happen? Say I am writing the question here again. If those 5 persons are arranged in such a way that they have to sit in a circle, then so let us check in this case what happens. Means when this arrangement is no more a row arrangement or column arrangement, and we have to arrange the things in a circular manner, in that case what will happen? So let us have a look on it. Suppose I consider a circle here. Say this is the circle. I consider a circle here. 5 places I shall consider now. Say this is the first place, this is second place, this is third place, then this is say fourth place, say this is the fifth one. Now as there are 5 persons, say we are considering the persons to be P1, P2, P3, P4 and P5. Now for the first person, as there are 5 empty places, the first person can sit anywhere of these empty seats. So suppose I consider that the first person is sitting here at this position. So wherever this first arrangement will be made, that will be considered as a fixed place. So with respect to the position of this first person, we are going to consider this to be as the starting point. Since this is a circular arrangement, in case of a circle there is no starting point, no ending point. The curve is closed. Therefore, we consider this to be the starting point. Considering this to be the starting point, the second person can sit here also, here also, here also, in this case also. So, as this is the fixed place, the possible, so for the first person, how many possible number of ways of making this arrangement, in how many ways he can choose his seat. there is of course one and only one option left in his hand to choose his seat. Why so? Because his position should always be fixed. Suppose in case of linear permutation, suppose we are making this arrangement, say this is the 5 arrangement. Suppose we are told that the first person's seat is to be fixed. Say the first person should always sit in the first place. This is the first place, say. The first person should always sit in the first place. So P1 should always be arranged in this first position, yes or no? That means his position is always fixed in this first position. So in how many ways we can choose this option? I mean, in how many ways can we make this arrangement? Of course, only in one way we can make this arrangement, because this seat is fixed only for the first person. So same is the case here in this case of circular permutation also, because although we are having here 5 vacant places, the first person can sit anywhere of this vacant places, empty places, but wherever he sits, that should be considered as the starting point, and that position should always be fixed. So we can write here what? We can write that here the sitting arrangement of the first person should always be considered as the starting point and his or her position should always be fixed. So what conclusion can we draw here? Therefore the possible number of ways that the first person can sit is equal to 1. So as his position is fixed, therefore there is one and only one way out in his hand to make his sitting arrangement. Now there were 5 persons. How many persons were left behind? Among these 5 persons, one person has already made his sitting arrangement. So in our hand 5 persons were there. So in my hand there were 4 persons left. So these 4 persons can make their sitting arrangement anywhere in these vacant places. Suppose this place is to be filled in. So how many options left in my hand to fill in this place? There are 4 options left. Then after, how many options are left for suppose I want to fill up this place. So after filling up this position, how many options left in my hand? There are 3 options, means 3 persons were left. So these 3 persons, any one of them can sit in this place. Therefore there are 3 possible ways of filling up this position. Similarly, after that, for filling up this position, how many options, how many persons are left in my hand? There are 2 persons. Similarly, only 1 person is left for filling up this position. So it is observed that here we can write the second person can sit in 4 ways. Then the third person can sit in, of course, one less, so 3 ways. Then the fourth person can sit in 2 ways, and the fifth person can sit in only 1 way. So of course we have to apply here fundamental principle of multiplication. So by fundamental principle of multiplication, what do we get? By fundamental principle of multiplication, we get, what do we get? Total number of arrangements, total number of arrangements is equal to 4 into 3 into 2 into 1, and before this, for the first position, this 1 we have to put. So ultimately we are getting here 1 1 ja 1, so ultimately we get this result, which is equal to 4 factorial. So this 4 factorial, actually initially we had 5 persons, but amongst these 5 persons, one person's position is always fixed. That is why in case of circular arrangements we have to follow this rule. Actually this implies what? If there are n number of persons, in that case, in this circular arrangement, the total arrangements can be made in this way, n minus 1 factorial, following this concept. If 5 is getting replaced by n here, then it will be, of course, n minus 1 factorial. So with the help of an example, that is how we can show this. Then coming to the next part, trying to derive the formula for finding out total number of arrangement. In this case means whatever I have shown here, that is to be explained next. So in general, the number of ways of arranging n objects, I mean n number of objects around a round table, means whatever we had discussed just now, is n minus 1 factorial. That is, in very simple words, I mean to be very simple, in case of this arrangement, what do we get? We fix the position of a particular person on the table. Actually I should write here at the table, because he sits by the side of the table, at the table. Then the remaining number of persons can be arranged, can be arranged in n minus 1 factorial ways. So that is the conclusion drawn from the illustration which I had given just now. So another concept, when we observe the things along a circle clockwise and anti-clockwise. So next let us come to this part: clockwise and anti-clockwise arrangements. So here in this case we consider two circles. Say this is the first one, this is the first circle, and another circle at the same time explaining the same situation we are considering here. Say 5 positions, a previous example only I am taking here. 5 positions I had considered like this: 3, 4, 5. Say here in this case I am writing positions of the persons as first person, then second person, then third person, then fourth person, then fifth one. Here also I am writing P1, then P2, I mean the second person, this is third person, this is fourth person, then this is fifth one. Now in figure 1, this is first figure and this is second figure. In the first figure, I mean in figure 1, in this figure, if we proceed anti-clockwise, in that case the arrangement becomes like, arrangement of the persons become like this: P1 followed by P2, then after P3, then P4, then P5. Again, in case of this figure, if we proceed clockwise from the first person, then this arrangement means the persons that we are going to meet along this circle will be P1, P2, P3, P4, P5. That means in both these two cases we are getting the similar arrangement. If we proceed clockwise and anti-clockwise along these two circles, then we are getting the arrangements to be the same. Means these arrangements are such that every person has got the same two neighbors. Means here in this case, if we proceed anti-clockwise, P1 has one of the neighbors as P2 and other neighbor as P5. And in this case also, if we proceed clockwise, then P1 will be having the same neighbors P5 and P2. The only difference is what? In the second case, P2 comes to the, actually P2 changes his position, means he changes his side, nothing else. So here in this case again one conclusion can be drawn. That is what? Since in this case we found same two neighbors, both clockwise and anti-clockwise, therefore to create such a situation in which same two neighbors will not be coming together. So let us check what can be done here. Thus this conclusion can be drawn. Thus the number of ways of arranging n number of persons along a round table. Thus let us check what conclusion we can draw here. The number of ways of arranging n persons, I mean n number of persons along a round table so that no person has the same two neighbors is half of n minus 1 factorial. So this is the formula for finding out the total number of ways of arranging n persons so that no person has the same two neighbors. So this is the formula here. In this case there will be a note. The note is what? While making a necklace or garland, there is no difference in between. There is no difference between clockwise and anti-clockwise. You will ask me why so. The reason is it can simply be turned over. Means whatever necklace or garland we take, this can simply be turned over so that clockwise becomes anti-clockwise. Actually, when the necklace or garland is simply turned over, suppose initially in what position it was, just after a few moments we just turned it over. In that case, clockwise will of course become anti-clockwise, and vice versa. Therefore, in this case, the number of necklaces formed, with small n number of beads of different colors will be equal to half of n minus 1 factorial. So that's all about circular permutations. Coming to some of the questions now. So here goes the first question. Question number 1. In how many ways can four persons, capital A, B, C and D, be seated at a circular table? So this question is very simple. This is totally related to the first concept whatever we had discussed. Means in a circle there will be four persons there will be arrangement for 4 persons, say this 4 persons. Anywhere wherever the first person sits, that will be considered as a fixed position. So in with us 3 persons were left who are to be arranged in this remaining 3 vacant places. So here in this case, suppose this place is next filled in, so there are 3 possible ways. Here also there are 2 possible ways, there is 1 possible way. So using formula, how can we write? The formula was what? For n number of arrangements, it will be n minus 1 factorial. So here we can write what? Here number of persons is equal to 4. Therefore total 4 persons can be seated in the circular table in how many ways? Of course 4 minus 1 factorial ways. We are using this formula here. So using this formula, we shall be getting here 3 factorial. That means 3 factorial means 3 into 2 into 1. So 6 ways of arrangement will be there. After that, coming to the next question. The next question is question number 2. Here what is said? In how many ways can 5 persons capital A, B, C, D and capital E sit around a circular table if there are two parts here, 2 questions written here. B and capital D sit next to each other. Sit next to each other. Second part is A and D, capital A and capital D do not sit next to each other. So in this case, coming to the solution part, how many persons do we have here? Given total number of persons is equal to 5. So coming to the first part, here 5 persons can sit around a circular table in how many ways we have to follow this formula n minus 1 factorial. That means here it will be 5 minus 1 factorial ways, which will give us the result 5 minus 1, of course it is 4 factorial. So 4 into 3 into 2 ways, so that will be equal to 24 ways. Again, in how many ways B and D can sit next to each other? Suppose in this circular manner, this is the position of B, this is the position of D initially, B and D. In how many ways can they sit next to each other? B should come here, D should go there. Either actually B can be towards the left of D or right of D. So there are only two possible ways of this arrangement. So therefore B and D can sit next to each other in 2 factorial ways. So for finding out total number of possible ways in which B and D can sit next to each other, what do we have to do? In this case, the total arrangements should be divided by this specific arrangement. Therefore, total number of possible ways will be equal to 24 divided by 2 factorial. This will be 24 divided by 2 into 1. So result will be 12. So answer is 12 ways here. Then after coming to the second part of this question, in the second part let us check what is said. In the second part of this question, A and D do not sit next to each other. A and D are not sitting next to each other, means in this case it will follow the rule of no same neighbors the person should have. So here in this case directly we can use formula half. This formula we can use here, half n minus 1 factorial, as already given in the notes, as given in the preliminary informations. So the second part of this question will be having this answer: possible ways in which capital A and capital D do not sit together. That will be equal to half of n minus 1 factorial. Here in this case n is of course 5, because total number of persons is 5 here. Since n is equal to 5, so we shall be putting here 5 minus 1 factorial. Here it is 4 factorial divided by 2. Then let us check what answer we get. Let us break it. 4 into 3 into 2 into 1 divided by 2. The result will come as 2 gets cancelled. Answer comes as 12 ways. So this is the answer of this second question. In the next videos we shall discuss more questions on circular permutation. Thank you.